When you go out to eat at an expensive restaurant with your friends or family, what do you say when...
We need to determine that light is in concentration with a concentration of 4 millimoles per decimeter. At this stage, we plot the absorbances of our dilution series on a graph like this. We can now use this calibration curve to determine the concentration of distilled water most absorbed by a containers called. You can place test tubes that look at how to use the colorimeter and how to analyze the results. Our unknown concentration per decimeter cubed. Finally, to test tube 6, we add 5 centimeters cubed of distilled water. This means that test tube 6 contains no glucose at all. Net this, we can now use this
we will make 10 and 0 point squares, so up in ones. Plot your points and either do a straight line of best fit or a curve of best fit. It depends what your results look like. If you look at my results, they do look like a nice curve of best fit. The 6 concentration, an extra tube for an unknown solution, which we'll label X, and distilled water. The distilled water will be your 0.0.
All right, if you have done a lab about mostly 0 times L, my molar absorptivity constant, times the path length of the cell. I've never done a spectrophotometry experiment where my path length wasn't 1 centimeter, equals your slope.
Current depth of chest. अर्थात wavelength where absorption is maximum is called as lambda max. अर्थात पोटेशियम परमैंगनेट के लिए 543 नैनोमीटर जो हमारे एक्सपेरिमेंटली यहाँ पर प्राप्त हुआ वो उसके लिए अवशोषण उच्चिष्ट है यानी कि लैम्ब्डा मैक्स है। तो हमने इस अवशोषण वक्र की सहायता से क्या ज्ञात किया है? पोटेशियम परमैंगनेट के लिए लैम्ब्डा मैक्स।
This lab you're going to learn how to refill test. So keeping my graph to determine the molarity of this solution. And once you know the molarity, screw the wash bottle and use my barrel dropper. Invert it one last time.
solvent while undergoing a rigorous and the grams and the mass percent of the screw. The purpose of this lab was to determine the percentage of copper in the brass screw.
Colorimetry. Verify Lambert-Beer's law for potassium. 0. Not the graph 1 of absorbance versus wavelength, which will give lambda.
Hello, today I'm going to show you concentration of my unknown sample. And that is using colorimetry to determine the concentration of a solution. Thank you.
There are, well, is darker. This is, we know, that, hence the same color. And that is the fundamental principle by which color.
In this video tutorial,
大家好，我是一名普通的做育人，这些大家平时以为很贵很贵。
light. Now, what do you mean by monochromatic light? Monochromatic. And let's red color. Whatever light which is getting absorbed.
Recording in progress.
兩加結氯液朗。加結黃液朗。No. Okay. So now shall we start the lesson now? All right. You will find this page. This is the summary part of this. So you may find our summary of the second last chapter of paper 1. And something about the periodic pattern, the variation in the bonding structure. This time we quite different from old practice of taking a look at the group. This time we would take a look at the periodic pattern. Whenever you talk about periodic pattern, you're going to read across a period. So of course the case will be more complicated because on the left hand side, in the middle, and the right hand side, they will have different bonding structures. The elements will have got some different chemical, some variation in physical property and chemical property. So that's why you need to memorize that. So nice that that type of pattern repeat itself while you go across from period 2 to period 3 and etc. But of course, once you do the group more downward, the case will be more complicated. Because you will have what we call as D block elements with what length F block, for example. So it will give you certain level of complexity in understanding the periodic table. Now, but just have a recap today. Now, first of all, is on your chemical property. All those to be noted. Remember, whenever you describe the bonding and structure, so you are going to mention what are the particles involved. Particles, for example. Now, particles, number 1, do the bonding between them. And the structure you need to mention. And 3, what bond or force to be overcome. I need to know its strength. Now, you need not to quantify the strength of a bond. Instead, just tell me strong or weak is enough. Okay, simply tell me is a strong or weak force, strong or weak bond is enough. So why do I say question 3? Point 3 is that, for example, for this part, what you need to overcome is van der Waals force, but not covalent bond. No need to overcome during melting or boiling. So even though you mentioned all bonds, all different types of intermolecular force present inside, whenever you use it to describe the melting point and the boiling point, what you just mentioned is the van der Waals force, the weaker one. Now, for the exact data of melting point, boiling point, you need to memorize, don't worry. Okay, but the form of the molecules in particular, you should memorize, especially these 3. Now, which would account for a shape, a very interesting shape of the variation in melting point. See, simple ripple, right? Up and down a little bit, but most of them, they are of a very low temperature. They happen at a low temperature. When you compare with silicon, a very high one, the highest peak, while for the other 3, okay, from sodium to aluminum, it gives you an increasing trend. Okay, so this is what you know it in when you describe it as melting point. How about electrical conductivity? It's easy. You just mention the delocalized electrons. Something about the presence or absence of it, or the number of delocalized electrons that may be found per atom lost. So we have got the two. Of a semiconductor, only a few electrons will be able, but will be energetic enough to jump to what we call it as a conduction band, so as to conduct electricity. So, the trends, first of all, from left to right, from metallic to non-metallic via metalloid or semi-metallic. Second, the melting point, it will have an increasing trend climbing the hill from group 1 to group 4 up to the highest value, and will drop down and remains as the lower value, depending on the molecular size. Being bigger, the melting point will be relatively higher when you compare among the four. And finally, it's about the conductivity. So mainly the conductor that we found on the left-hand side, while on the right-hand side is non-conductor, while the group 4 mainly for silicon or for boron group 3, it is semiconductor. So you may know, right? So the previous three elements, they will have that trend. So this is what you mentioned for non-metal. Remember that, okay? Remember the molecular formula of sulfur as 8 crown sulfur, phosphorus P4, chlorine Cl2 Ar monoatomic. And point number 5 and number 6 we just covered last lesson. We talk about its oxide form. So mainly on the left-hand side, oxide is metal oxide, ionic oxide, basic oxide, ionic oxide. Okay, and then on the right-hand side is non-metal oxide and covalent oxide, and also acidic oxide. Okay, so that it will give you a different structure, the melting of point of it, whether or not it dissolves in water. So these two is a very special case. Even though I talk it, one is amphoteric, one is acidic. Both they are not soluble in water, but they will react with the acid-base counterparts. What do you mean by that? For example, if you talk about SiO2 being acidic oxide, so it itself behaves as an acid. So they will found a base to react to form salt and water. How about Al2O3? They will have the dual property, okay? The dual property of performing acid or alkaline. So it really depends on the nature of counterparts. If you mix with an acid, the Al2O3 may act as a base. Okay, if the counterpart is just a base, the Al2O3 is just an acid. So they will react to form salt and water. And today and this year, the last day, okay, yesterday we have got the DSE chemistry exam for the very last question. It is the acid type questions talking about the acid-base behavior of the periodic oxides. This is the one. So surprisingly, in the past, the students will needed to write down the equations. Okay, but in the last year, but the paper this year we will not have it. But you still need to memorize it. Now in your final exam, we, Mr. Wang and I will work together to make a paper 1 with you. So which covers all topics in paper 1. I repeat, all topics. So altogether 12 topics up to this book 5. Are you ready for that? Okay. But of course, we would I will still continue the teaching of elective parts, but for final exam we need not ask because the scope will be too heavy for all of you. Now, so memorize the equation. So today recap of this. Do you still remember that? Can I take a look on metal first? Metal on top, C, D, and E. Let's have a try. Sodium, what structure they are having? This one, C. Whenever you talk about structure, a metal, of course, it is giant metallic, right? And magnesium forming basic oxide, aluminum forming as what oxide? What is that? D. What oxide? Now, so it seems quite strange, right, for that organization chart. These two, they are of the same category. About this one, we talk about totally different things. Very strange. So we have got 3 words to choose, right? Acidic, basic, and voltaic.
And voltaic.
Yes, and voltaic. And voltaic, which means what? What mean by voltaic?
It can act as both acidic or basic oxide.
Yeah, that's right. So this is they will have a dual property of behaving an acid or base. So both they will share the oxide MgO and Al2O3. They both will have got a structure. What is the structure? What is the structure for E? Listen, what is the structure they're having? Listen.
Ionic structure.
Giant ionic. Okay, yes, that's right. It's giant ionic. So I would like to elaborate more on that. So for that 3 metals, they both will have giant metallic structure. But if you want to mention it as sodium, magnesium, and aluminum, they'll have basic oxide, and voltaic oxide respectively. While the 3, they commonly share the same structure, giant ionic structure. How about that one? A, what is that? What first string? Element, oh, same category. That 3, you talk about the same category. So A and B. A is a semi-metal. And this one, we've got non-metals. We'll talk about 3 elements: silicon, phosphorus, sulfur, chlorine, argon. So you take a look at silicon. So silicon itself, it has a what structure? 魏俊通. Yes, tell me what structure what silicon has. And Magalok, could you please answer F and H? Majento, please answer G. While for 陳許廷的 will be responsible I and J. 學校日 K. Okay, who come first? That's Majento, giant covalent. Yeah. So we focus on silicon first of all. Giant covalent structure. And Magalok, tell me F and H. Silicon, they will form what oxide? Weakly. Can you see the word weakly? Weakly. What oxide with what structure? Magalok. Silicon oxide. So I know it's silicon oxide. So can you tell me the nature of the oxide? You see that weakly. So this is an adjective, right? This is Yes, this is adverb. Well, this is adjective. So this is weakly acidic oxide with what structure? SiO2. What is the structure they're having? Magalok. SiO2. What is the structure? They should be the same as silicon, right? Giant covalent. One for non-metals, not simple molecular. Magalon is not simple molecular. It's giant covalent. Go back to Form 4. I'll read again, revisit that because it's quite rather confusing with CO2, right? CO2 is simple molecular. SiO2, both having for the same group 4 oxide. One of them is giant structure, the other is simple structure. And for the others, so you may find Chen Huiting's contribution, acidic simple molecular structure. Yes, that's right. Acidic oxide, they will form a simple molecular structure. So to name a few, the oxide, anyone who can suggest the name of the oxide or the formula of the oxide of phosphorus, sulfur, and chlorine, what are they? Lam Junhin, yeah, P4O10 for phosphorus. Lam Junhin, can you think of sulfur and chlorine oxide? One of them, just give one name or one formula.
Sulfur dioxide.
Yes, sulfur dioxide, good. Sulfur dioxide, sulfur trioxide is also okay. How about chlorine?
Oh, ClO.
Cl2O, okay? Yes, that's right. And all right, so you may have got this. And for argon, they are non-monoatomic. So we have got simple what structure? Straight simple molecular structure. But they will not form oxide. So we will not describe argon having an acidic oxide, basic oxide, or voluntary oxide. That's meaningless to tell so because first of all, argon will not form oxide. So you can get what I mean, huh? So we stop at this part and you will go to this, the MC. Question 2 to question 16. We have got 15 questions. 15 questions. So I'd like to post the Google form to all of you. Please have a try on that. Please finish your questions and submit through Google form. I will check the answer with you. 15 minutes, 47. Can I have it stop at 11? Okay, can I stop at 11? Because there is no calculations. I'm sure most of you can do it very quickly. Please do it now. Now, common students are just posted the Google form. Now, please put your answer there. This is the one. All right, the time now is 10:56. 4 more minutes to go. If you're finished, you may put the answer into your Google form and we would like to check it. Now wait right away, okay? Based on your answers. All right, the time now is 11. Could you please put the answers in the Google form? I would like to check. We have got 15 of you submitted. How about the other 8 students? I'm now waiting for you. Okay, for more yet to submit. Finish. Now, shall we, for the other 4, please do it. We are now waiting for you. You have difficulties, please PM me. Now, so we take a look on the questions one by one. Now, after 1 minute, I just wait for 1 more minute to wait the final 1 or 2 students to submit your work. Now, okay. So the average mark is 12 out of 15. Most of you have got a good job, but I do hope you can do the same in your final exam. Some of them you may have memorized it during bonding and structure, but some new things, including the more detailed explanation across the period of what I mean is the metal melting point, or the electrical conductivity, etc., and as well as the acid-base property, right, of their oxides. Those elements, especially period 3. So this is what you need to be highly aware of, right? So you need to memorize these parts. Now we come to the questions. I would read the questions and pick up some questions in which you may have got some confusion. For question 2, no problem. It is about D, because whenever you talk about the Van der Waals, the weak forces, right, as mentioned, by a very low melting point of it, it must refer to weak forces. So this is a weak Van der Waals force impact, to be more specific. While for question 3, you are going to see the variation in electrical conductivity. So underline the term. So every time, even though you'll be given the very similar graph, please read this one very carefully before you choose your answers. Otherwise, you'll be trapped and quite number of you have got some other graphs. Okay, but indeed, if you want to talk about electrical conductivity, you are now mentioning metal for period 2, lithium and beryllium, and then carbon in terms of graphite in which it conducts electricity. Maybe some of you, they will be struggling on a certain part, just like where not graphite is a good electrical said to be conductor. How come I place it? The relative conductivity is it lower or higher than metal? You may get confused about this, but don't worry. As long as you choose lithium and beryllium with this trend, okay, you know that boron being a semi-metal, okay, a semi-metal, so you may get the answer correctly. Okay, so leaving behind. Okay, leaving behind is just the other two. Okay, so you may I know some of you may have got confused about that. And for D, for question 4. Question 4, the answer is B. This one, you are going to refer to the fractional distillation of liquid air, and you may find nitrogen on top, oxygen down near the bottom, while in between is argon. Just remember, the flow, the fractionating tower from top or to below. Just remember that in the fractionating tower. So you base on this, and you can get your answer. Of course, you'll find B is difficult to be distinguished. You check for the remaining. Okay, so you may find that this was molecules. This one is giant structure. So lower melting point, does it make sense? Somebody say that silicon is a giant structure. Giant structure, no, not simple structure. Okay, remember, silicon is a giant structure, not simple molecular structure. Even though you talk about, but even including is oxide. So melting point of aluminium is lower than that magnesium, lower. No, it's related to what? The metallic ion size, to charge, the number of delocalized electrons per each metal atom lost. And for A, the boiling point of argon and neon, lower. No, it's relative, is because it's difference in size. This one is having a larger size. Of course, the van der Waals force is larger. So A must not be chosen. Question 5. Question 5, you talked about which letter shows the position of elements with the highest melting point. Highest melting point. So it's not that difficult. You choose the one which is rank number 14, silicon, and you can get the answer. Question 6, which of following statements concerning aluminum oxide is incorrect? Choose the wrong answer. So when mixed with water is not soluble with water, so they will never having a solution being smaller than 7 or greater than 7. Now, even though you try it as equal to 7, that doesn't mean aluminum oxide is neutral. It's because you are just measuring the pH of water only. While you observe the Al2O3 is still not dissolved. So choose the incorrect answer. The answer is D. The choice is question 7. Question 7, slightly alkaline solution when dissolved in water, slightly alkaline. So this is the one. So you are going to have AgOH2 with relatively low solubility. So we call that slightly alkaline. But once you talk about Al2O, right? Some chemical just like group 1, for example. So the solution to be formed is a strongly alkaline solution, because it is totally dissolved in water, fully dissolved. So this is not the slightly. It's not slightly. So question 9, most of you answer question 8. Question 8, the answer is A. Silicon dioxide solid, single covalent bond between silicon atoms and oxygen atoms. Still remember silicon 4 hands, oxygen 2 hands. So all those covalent bond. And question 9. Question 9. Acidic oxide. The answer is C for sure. D must not. Okay, it's a noble gas. It's rather unreactive. How about C? What is that? Group 6, right? Group 6. Oxide. So is still a non-metal oxide. So non-metal oxide forms acidic oxide. Just remember. So question 10. I'd like to draw your more attention on this question because quite a number of you chose D. Now remember, the term is added separately to water. Should be noted. Can you see that? Added separately to water. So the answer is C instead. D is wrong. Why? So you may see the two Al2O3 and SiO2. As said before, why you will measure the pH of a solution mixture being 7 is not because they are neutral oxide. It's because you are just measuring the pH of water. That two chemicals are water insoluble. So it doesn't play any role in exhibiting the acidic or basic property of the solution. Indeed, it's not a solution. You need to be more exact. It's just water. While those particles that will just settle in the bottom, that two still doesn't mix. 11. The answer is B. No need to mention too much about that. Molecular structure can be found on non-metal oxide. Question 12. Question 12, incorrect. Choose the one which is incorrect. So the metal reactivity water must be correct, but this one is most reactive because it has just got one outermost shell electrons. It will be lost so readily. Incorrect. Choose the incorrect answer. So basic strength of the metal oxide will be this order. No, quite the opposite. The most basic oxide can be found in group 1, while the base strength of the metal oxide decreases instead across the period. 13. The answer is D. If you want to talk about the essential metal has a very oxidation of +6, right? This one, SO3, 2 minus is +6 oxidation number. Surprisingly, quite a lot of some of you choose A. How come? I don't know. Question 14. Question 14 is D. Sodium oxide, not amphoteric, is a basic oxide. Conductivity, yes, that's right, because of mobile ions. High melting point, of course, yes, because it possesses giant ionic structure. 15. Put a star here again. Oh, only 59.1% will choose D. Okay, whilst many of you choose B instead and think question 2 not chosen. How come? Is aqueous solution is a reducing agent? 點解嘅? Why would so many people didn't choose statement 2? 點解嘅? 搞咩嚟嘅? 唔記得咗，唔記得咩叫 reducing agent. So reducing agent is a process in which it reduces the other, right? While it is oxidized. 唔記得咗。Oh, sulfur dioxide. Oh, I see. Somebody is talking about, you mean that sulfur dioxide dissolved with water, would it form sulfuric acid instead? Now, indeed, it's wrong. SO2 react with H2O directly to form sulfurous acid, first of all. Okay, sulfurous acid. while sulfurous acid, it is a reducing agent. Now, having sulfide ion inside, being reducing. Okay, so we have got the oxidation state being +4. Now remember that this solution doesn't involve any redox until I stay, if I leave the sulfurous acid for long. Question 16. Question 16, the answer is correct for the oxide, for that purify oxide. This is correct. Melting point increase, that must be wrong. Okay, the lower melting point oxide can be found on the right hand side. Electrical conductivity increases. Of course not, right? Increases, we will call the trend like this. No matter a curve upward or just what, altogether it seems like it's upward trend, which means non-metal oxide would be highly conductive in molten state. No, it seems that statement doesn't make sense. A part, A is the answer. Questions. Now, shall we move on to long questions? You may find some, because time is not enough, I just choose two questions to cover with you. Question 22. This is the question on periodic pattern. The other one I would like you guys to try is the acid base behavior of oxide. Okay, so the later question will be something like this. So take a look on question 22 first. 22. Because 21 we have just covered. This one just draw the trend. I'm sure you can manage by yourself. Question 22. What is the general pattern in the melting temperature across the period in the periodic table? How will you describe the trend? It increases, right? From group 4 to group 4, 1 to group 4, while the melting point of it for nitrogen, for oxygen, fluorine, and neon, they just remain at low value. So whenever you talk about the pattern, the trend description of the variation of melting point, you need to really mention it by writing like from group 1 to group 4. I'll mention it, but not merely telling increasing, decreasing, right? Because it's not so absolute amount that 8 elements. It gives you some variation in between. So you write down from where to where the melting point increase. Okay, while from group 4 to group 0, the melting point, they are relatively low, but I would not I cannot find it as an increasing or decreasing trend. So just tell it compared with group 1 and group 4 to group 4. Okay, those are the melting points. What I mean is group 5. So strange. For group 5 to group 0, 5, 6, 7, the other 4 they have relatively low melting point. How is this general trend related to the different types of elements? Oh, so what patterns do you find? Monya?
佢哋嗰個 structure
general trend with different types of, yep. Can you please elaborate more?
metal 嗰啲有giant metallic structure， 所以佢哋個 melting point 會高啲。
Oh yes, metals. They have got giant metallic structure. So generally they have the high melting point. Yep. How about the others? The other elements?
然之後metal 來或者carbon 佢哋有呢個giant covalent structure。
Metalloid, carbon, etc. They have giant covalent structure. Yes. And then so
high melting point.
Yes, high melting point. Finally.
佢剩低嗰啲係 simple molecular structure。
Simple 剩翻嗰啲。So what?
Non-metal.
There's many non-metals. They are having simple molecular structure, so they will have a relatively low melting point. Okay. So clever. Okay. A person who was born in 3rd of May are so clever, so handsome, quite nice. Happy birthday.
Thank you, Mr.
Yes, that's right. So we come to see what this means by the term periodicity. Periodicity, Cyrus.
Periodicity is the pattern of physical properties of elements across periods, every period.
Every period. So how would you relate to the periodicity, periodic? So do you mention anything about the terms? How to describe periodic? Some, you tell me the variation in the pattern, right? But the pattern, how you relate to the term periodic? Hi, Cyrus. Periodic.
Yes.
Of course, across the period, it seems like repeat itself, right? But it is not just repeat. It will give you a very similar pattern that will occur again and again. So we call it recurrence of the same pattern. So can you get my point? So because periodicity, which means that they will repeat something, right? So they will occur again. Okay, so recurrence of the same pattern. So for example, what you mentioned is the variation of physical property, for example, across. So of course, periodicity, of course, you need to mention the comparison between different periods. So across different periods, we call that periodicity. Can you get it? So because of that type of comparison would we realize that the pattern repeats. Sorry to understand what is that about the term periodicity.
Yes, I understand.
Yeah, but of course, but I do think most of us will understand. But the way to present the wordings, right? You need to find a way to describe that. Okay, because first of all, compare the elements in different groups, and then take a look on select certain physical property from left to right and try to see if that pattern repeats. So if you love chemistry, you may get to know, if you want to talk about periodicity, now you search on the web, periodicity, and then chemistry, you search. Now you may see so many of various periodic patterns that you may find. So, and it will give you some more ideas about periodicity. So state one other physical property that we consider periodic in relation to periodic table. So name a few. Besides melting point, some of you may think it is boiling point, electrical conductivity, electronegativity, this one, electronegativity, 電負性, the green arrow, atomic radius. Can you see that atomic radius would also have a decreasing trend across the period? Okay, so to name a few. Now, and second thing, if you just take a look at the chart, increasing and decreasing trend only, right? But you would see like this periodicity. If you really go into detail to know the variation, exact variation, the melting point, for example. So this one will help you better understand what is meant by periodicity. So do you realize, right? It seems like a mountain, right? Climbing up and down, up and down, up and down across a period. Okay, do you realize, right? You may find period 2 for QC carbon here, right? Is period 2, silicon is period 3. Vanadium, this one is period 4. And in between, I insert a very large batch of what is transition metals. Do you realize? But you may just unhide those orange parts just so you may see the same trend increase at the maximum climb up and then down. So we call that periodicity. You understand? So this is what I would like to show. You may type some other property into your book, into your web, and you may find more. And the last questions on exit phase property. Try to find a big box, right? Question 29 or 30. Which one would you like to have a try? 29 or 30? Which one? Now we choose one of them. 29 or 30? 30, yep, you can. 30. There are trends in the properties of oxides of period 3 elements across the period. Also use the above 3 oxides. Describe the trend in chemical formula, structure, bonding, action of water. You include equations in your answer, where appropriate. Yeah, so chemical formula is easy. You may compare the 3. That is Mg. Now, because it's exit type question, you may need to write down in paragraph length answer. But to us, I would like to draw a table instead, because it seems easier to manage this part, to try to make it as a neat manner. So first of all, chemical formula. Chemical formula of oxide being MgO Al2O3SO2. Okay, and what else? Describe the trend. First change, right? Besides writing this, no marks, you need to mention trend. What is the trend? What is the trend? What is the trend?
Trend of mel.
Yes. 即係咩？
咩 trend？
佢問你 trend in a chemical formula。佢條題目係咁寫喎 ，describe the trend in chemical formula。好奇怪喎 ，very strange, isn't it? Right? So you write down the chemical formula first of all, but you still cannot get marks because you did not describe the trend.
Ratio 應該係。
Yes. What ratio?
The ratio of 嗰個element to oxygen 係 increase across the period.
Yep, good. Ratio of the elements or of the elements, no matter of the other elements. Oxygen to element, right? You mean oxygen to element?
Element to oxygen 係
element to oxygen
係 increase
element to oxygen increase
decrease
點啊？
係
點啊？
搞唔掂。
oxygen element 啊？你想講咩啊
？ratio of oxygen to element 係 decrease 緊 across the group.
Oh yes, which means that for each atom, okay, combining to oxygen, right? The number of oxygen that to be used increase, right? Per each element, increase in number. 可以咁寫啦。There is an increase in number of oxygen combining with one atom of the element increase. So whatever way to express is also okay. What Ms. Lee has suggested is also okay, as long as you would mention something about a number, the number ratio, the concept. Okay, is also possible. Now, besides, you may think of there is an increase in oxidation number of the elements, for example. Okay, of course, in the oxide. So by doing so, you can also describe the trend. Can you get the point? So the second one, of course, we need to just take a look on the formula and try to take a look at the ratio. Yes, that's right. So if you write down this one is 1 is just 1. It is what's 1 is 1.5, and this is 1 to 2. Can you get my point? The ratio. You may also mention it like this way. Increase in number of oxygen per each atom. Second, structure and bonding. So you split that two, and you can get what is the difference in the structure and bonding. Lâm成康. Lâm成康, difference bonding.
Magnesium oxide 同 aluminium oxide 係 giant ionic structure， 然之後sulfur dioxide 係 simple molecular structure.
Yep. So it's just the beginning. You have to tell furthermore about the bonding environment. So ions are held together by strong ionic bond for this. And while this one, you talk about molecules are held by weak van der Waals force, okay? Van der Waals forces, etc. So you may need to mention about bonding as well. 3, action of water. So what happens about that 3? Action with water. So of water. 3 different statements. 好像 action with water.
係首先佢MgO 如果佢加落水度就會有個 alkaline solution， 跟住如果
What is that alkaline solution? What is that alkaline solution?
MgOH.
Yes, but it's a slightly soluble in water. So somebody would love to mention is the word weakly alkaline solution. How about the other two?
咁跟住aluminium oxide 就會係因為佢係 insoluble 咯，所以就係冇 reaction。
Yes, water insoluble oxide, so no reaction. Yeah. How about the last one?
咁跟住 SO2 就會 react 就會出咗一個 acid sulfuric acid
Sulfuric acid, H2SO4, is it?
H2SO3
Yes, we call that as an acidic solution of sulfurous acid, okay? SULPHUROUS, not RIC, okay? Sulfurous acid. Okay. So Al2-3 is water soluble. Last question, Last question is an additional question. 王奕朗 Al2-3 is said to be an amphoteric oxide, but this oxide itself is not water soluble. How will you know that it's amphoteric? Now that type of question has been assessed, right? Has been tested. Wang Yulong, are you here? Hello, Wang Yulong. Gone? 係喎，冇咗個名喎，要咩？鄧俊熙。
We add the aluminum oxide with acid and alkaline together. Two set up.
咩㗎？講咩
啊
？Separately you mean separately?
Yes.
Separately. While the equation, you guys need to write down the equation between this one, Al2O3, we have acid, Al2O3, we have hydroxide ion respectively. Now, this is what you need to know. 成日問㗎啦呢一個，得唔得？ To tell it how come we will describe it as amphoteric. Now, of course, in this question, I will not ask so, right? Original question, it doesn't ask so, but they is easily or more commonly asked, right, in this to form salt and water. So you have to memorize the formula, right, of those salts. Okay, so much for that. Do you feel better? Can you manage to do the rest of the questions by yourself? Okay, before yep, I just read your level understanding 7, 8. Most of you yes. 7 to 8, quite nice. So how come Wang Yulong just come in and suddenly left? I cannot find him. So strange. I need to check with him. All right. Now so much for today. It's time to have a break. Thank you for your time. See you. Bye bye. Bye guys.
拜拜，先生，生日快樂，
生日快樂，
拜拜 ，thank you，拜拜，
拜拜，先生，生日快樂，
拜拜，天上生日快樂。
哦，多謝你，拜拜。
生日快樂，拜拜。
生日快樂，拜拜，拜拜，thank you，拜拜。